All right. Welcome to the third KCS talk of this semester. The speaker for today is Mr. Adib Mosharrof. As you can see here, a second year CSP student. The title of his talk is Organizing Deep Learning Projects. Okay. The speaker will share different problems and requirements that might arise in a project, and the approach is needed to resolve these problems. Okay. And he will start with how he initializes a project and the tools he uses to maintain his code base. Okay. The speaker will also share some useful Python practices and the libraries that he uses for his project. Okay. And finally, the speaker will talk about different problems that he had faced and the decision or the design decisions to overcome this problem. Okay. So let's welcome the speaker, Mr. Adib Mosharrof.
Hello everyone, welcome to this week's Keeping Current talk. As Professor Cheng already mentioned, my name is Adib Mosharrof and I'm a second year PhD student in the CS department. And today's talk I will mainly focus on how you should organize your deep learning project. A disclaimer from the beginning is I won't be talking about research. Particularly, I will mainly be talking about how you should write your code, how you should organize your code so that you can do your research better and you're not stuck with implementation details of a few things. Okay? So it's mainly about coding practices and those things. Okay, let's get started. So in this talk, I will talk about a few things like what are the steps in a deep learning project, then the importance of code organization, the IDE that I use, talk a little bit about Python environments and practices, and some libraries that I use, third party. And then we talk about command line arguments. There's some libraries that we use to fulfill that. Moving forward, we talk about Codebase, how to organize your directories, the code modules, how to model data. I'll show an example of how I model the data. And then we'll also talk about training deep learning models, some good practices that you should follow with your training. And then when you're doing multiple experiments, you need to track your experiments. So I talk about tracking experiments. And then at the end, I talk about keeping a research journal that will help in the whole process. Okay? So let's start. My main research focus is in deep learning. I work with Professor Adib over here. He works in task-oriented dialogue systems, and that is my main research focus. Before I started working with Professor Adib, I used to work with Dr. Nathan Jacobs, and with him I mainly focused on computer vision, geospatial images, and some of these image-related topics. And before that, I have some work experience where I was a machine learning engineer at a company for the summer. And then before that, I was a software engineer where I was a full stack JavaScript developer, ASP.NET backend developer, and also web development instructor. So a lot of the code that I write is based on these experiences that I had before, where if you are a software developer, you try to write code in such a way that you, your team, and everyone else can utilize it well. So a lot of those practices came out over here. So let's briefly talk about the steps that we normally have in a deep learning project. So we initially start with getting a data. So normally, most cases, there are data sets available out there. We just use those directly. In some cases, there might be the case where we have to create our data ourselves. But nevertheless, you have source of data. That is the first step. The next thing you want to do is you want to clean that data, make some small changes to that data so that you can fit that data into your model. So in most cases, the raw data that you get, you cannot feed that raw data directly into a machine learning model. You have to do some process in between, and then that processed data is then fed into the model. Next, so we come to the train step. You have your data ready, you pass the data to the model, and then your machine learning model will train and try to optimize. And then after that, you must have an inference step where you see how well your model did. And based on the results, you see that, okay, with these ideas, it worked like this. Let's try out a new idea, and then maybe go through the whole step again to try and improve. So basically, this is normally how I work in most deep learning projects. There might be cases where things go a little different here and there, but in general, we can assume that this is the general structure of a project. Now, basically what happens is that over time, as more requirements are brought in, as you try new ideas, your source code files become very large. And as new features come in, old features might break, and you do all sorts of adjustments, and your code might become a little error-prone. And it becomes quite difficult to read what you wrote. And there's a really nice meme in the programming community, is that when I started writing the code, only me and God knew. By the time I finished, only God knows what I wrote. So this is something a lot of us programmers struggle with a lot. So we have to find ways on how to make sure that we remember what we wrote. And also, what happens is that over time, the code is difficult to read, difficult to understand, and difficult to extend as well. And the term we use is your code becomes a code spaghetti. So I have a picture of this, like what other people see that, okay, your code works really well and it's doing some super cool thing, but you know deep inside that you wrote some pretty bad code, and if you have to make some changes, it might be quite difficult, okay? So that's the picture over here. So normally, if you are a software engineer, you have a lot of guidelines. They tell you what you should do. You have senior members working with you who say that, okay, follow this pattern, structure your data, do things in a certain way. So there are like lots of different patterns, as you can see in the picture over here. I don't want to go into too much detail in describing them. But it basically, they have lots of design patterns, guidelines, architectural designs, and all those things. And these guidelines have been developed over many years, and they've been tried and tested by people in the industry. They have really good frameworks, a lot of resources. But when we come to machine learning projects, machine learning hasn't been there as long as software engineering has been there. So it's definitely has fewer resources, fewer people working on it compared to software engineers. So basically what happens is that there isn't too many guidelines. Normally what happens is that whenever you start with a machine learning project is you first do a proof of concept code, and if that works well, then you continue on that. And normally what happens is that people build on top of that proof of concept code, and it becomes quite challenging if you don't follow a good pattern from the beginning. And we already said there are no official guidelines or best practices on how you should write these machine learning code bases. So in this seminar, I'll try to explain some of the things that I follow. Okay, so let's get started on today's talk. So the first few things we need to keep in mind is what is our end goal? What do we want with our code base? We want our code base to be readable so that we can easily take a look and understand what is it we're doing over here. We want it to be flexible so that we can easily add new features but at the same time make sure that the old features that we had, those don't break down. Okay? And then,
I have a question.
yes.
When you say readable, do you mean readable comments or the code itself?
The code itself. Like I believe that I prefer not to write comments in code. So you write your code and your code should be readable, because if you add comments, like my belief is if you add comments to code, then you have to update two things. Like if you update your code, you have to then update your comments as well. And we are lazy people and we normally don't update our comments. We only update our code. So basically what happens is that after, let's say, a few months, your code does one thing, but the comment says your code does something else. And then a few months later, when you come in, you will be confused. What is going on over here? So my general practice is when I write code is that the code that I write, that should be kind of like I'm reading English, kind of like that. And so if you kind of write in that way, then you won't need too much comments. You can add some comments sometimes if it's too complex. But yeah, that is basically what I mean by reading. That you see your code and then you can understand what's going on.
Well, your comment does not reflect what is really written in the code. For most of the people, we read the comments first, right?
It's a debate we can do later, but like for small or medium projects, I feel I haven't written comments that much. But maybe if I'm developing a library where I need documentation, in those cases maybe I would add lots of comments. Yes?
I'll just throw in, I'm not a big believer in commenting, I'm a very big believer in documenting.
Yes.
So I like the first thing I want to read is a separate document that says what the overall structure of the code is.
Yes, yes. Anyways, let's move on. So basically we want our code base so that we can easily maintain it, so that if small requirement changes come here and there, we can easily make do of that. And then if other people in our team want us to work with that, we have to make sure they understand those as well. Okay, so the first thing that I want to talk about is an IDE. So this is another debatable topic, but I'll present my views or my choices, and you guys can say that it's not good, but it's fine. So the idea of my choice is VS Code, and I have some reasons why I say I like this. So the best thing about VS Code is that it is light. And before I had a computer that wasn't super powerful, when I tried out other IDEs that were really good, but they were heavy, they would make my machine slow. So the overall development experience wasn't good. But an IDE like VS Code, which is very light, it's almost like a text editor, you can use it in almost any machine, and it won't consume too much resource. The next thing that I really like about VS Code is the debugging features. That you can debug code really easily, line by line, and it's not too difficult to set that up. It has a lot of good extensions, so anything you use in other editors or things that you like say that, okay, maybe this is something that I can't do in VS Code, search the extension package, you'll see that someone has developed some package that will allow you to do that. Another feature that I really like is called remote SSH, that with that you can remotely SSH to any server and load the file server from there. I have a separate slide for that, so I'll go into details of that. And then the community of VS Code is really good. If you search in Google that this is not working, that is not working, how do you solve this, how do you solve that, you'll always find someone answering your questions. And also you can customize a lot of things. They have a settings.json file. You can write small settings over there to change the font size, the color, icons, anything you want, you can customize almost everything. So let's talk about debugging, how to set it up. So basically in VS Code, if you want to debug or run your files, you need to have a launch.json file that you can see over here that I have. So basically the launch.json file, I'm showing an example of launch.json file from my code base. So basically, you have to say a name, whatever you want. So this launch configurations, I have a lot of launch configurations. You can see all the launch configurations over here. And here are 2 examples of these launch configurations. So basically, you have to say what the type of your program is. Over here, it's Python. What is your program source path? So I'm saying it's in the trainer.py. And then you can also specify the current working directory. And if you want, you can pass in extra arguments to your program. And this is another feature of Just My Code that helps you to debug third-party libraries as well. So as you can see over here, when you have a new file, you want to run that or debug that, you just write this one thing, copy and paste it, just change the name of the program, and then you have another run configuration as well. And then you can say, start the program by running without debugger or with debugger, and that's pretty simple. I know there are other systems and IDs out there where people have really struggled to set up how to debug, but it's really easy over here. And yeah, so I say that like if you debug your code, you can find bugs much more easily. Okay, so another feature of VS Code that really attracts me is a remote SSH. So basically, what I said over here is that so we have a UI of the remote SSH. So you can connect to a host using SSH, and then you'll see your target things over here. You can say which machines you're connected to, and you can load the file system from that machine. So basically how I use remote SSH is that in the lab over here, I have a machine where all the things are in the CS home directory. But when I'm working from home, I open my VS Code and then I SSH into the lab machine that I have over here and then load the file system from the CS home directory. So when I'm working at home, it feels like I'm working in the lab. I don't need to connect to remote desktop or anything like that. Since in the lab and in the home, both places are loading the file system from the same location, I have the same file system in both places. So I don't need to make a commit, push, and then go home and pull to get the latest updates. Since both places I'm sharing the same file system, it's like I haven't changed my work system. So this is the feature that I mostly like about VS Code.
Let me just point out that there are other ways of mounting using Unix a remote file system through SSH. And you don't have to have VS Code to make that work. But it's nice that it's there.
Yes, I do that using a program called SFTP drive where I mount the CS home directory, and with that I load other programs. But the thing with VS Code, with SSH over here is that you get the local development experience fee. So you get the file, and then you can run your file, debug your files, and edit and do everything. And you won't feel like you're not working in your lab machine. It will feel like even at home you're working in your lab machine. That's the biggest advantage.
Oh, there's something besides what you just mentioned that works also. But we can talk about it.
Okay, sure. Yeah.
I just wanted to mention, if anyone doesn't use VS Code but wants this to be basically the same thing, look up SSHFS, SSH file system.
That's what I'm referring to.
Yeah. So you can use that on Windows too, but you have to install some weird stuff.
Yeah, so but basically I use another tool as well over there. I use something like that where I load the file system in a separate drive in Windows, and from there I can work as well. So both systems work, but the good thing over here is that this is integrated into VS Code. You don't need anything else. So that's the main advantage. So also another good thing over here is that you can, like even in the lab machine, in the lab over here, let's say you have 3 or 4 different machines and you want to run your code on machine A, then also machine B, machine C, and maybe you want to debug on machine C. So the use case that I have many times over here is that the lab machine that I use has 1 GPU, but then there are some lab machines that have 2 GPUs. And maybe I want to run my code over there and I see that it fails, and so I need to debug. Why did it fail on multiple GPUs? And so using this VS Code, I can debug and then find out, okay, in that configuration, why it did not work. So these are some small things that I can quickly set up and quickly do that I feel really adds value to the whole development experience. Okay, so connect to multiple machines, connect from multiple machines. Okay, so another thing that people use a lot is Jupyter. So I want to discuss my use cases of Jupyter. So when I use Jupyter, I mainly use it to, let's say I have a proof of concept that I want to try out, and I do that using Jupyter. Let's say I want to have a data set, I want to do some exploration on it, have some quick graphs, quick data frames to see what's going on. I mainly use Jupyter for that. And mainly if I have anything that I want to quickly have a quick and dirty solution, for those reasons I use Jupyter. But there are some drawbacks to Jupyter that help, like for which I don't use Jupyter for, let's say, a whole project. Normally Jupyter is in one file, and it's pretty hard to organize if you have a single file. And you don't have a separate environment management, so you need to do all the installations using pip install, those things. And then you need to run multiple blocks. So if in case you forget to run one block and then you run another block down below, you'll see an unexpected error. And these will happen more if you have a very long Jupyter file. And then this gives rise to a lot of errors that maybe is not in your code, but this whole thing, everything in one file, multiple blocks, could give rise to a lot of errors. So that is why I suggest when you actually start off with a project that will be quite big, or you know you need to work on it for a long time, it's better to write Python files and not use Jupyter notebooks for that. Again, this is a topic that can be a long discussion, so we can talk about this later. Okay, so we got a few things out of the way, so now let's talk about Python. So the first thing that we should do whenever we set up a project is to set up an environment for your Python project. Many times what I did when I first started writing things in Python is that I didn't know environments existed. So I have a Python installation in my computer, all the packages that I need, I do pip install, and it works. Next time I have another project, I need to do a pip install, and over there I see that I cannot install this package because it has a conflict with something else. And since I'm installing all things in the global Python environment, it gives rise to a lot of problems. So the best way to approach Python environments is to have separate environments for each of your different projects. Whenever you have a project, create a separate Python environment just for that project, and then when you start working on that particular project, activate that environment and do everything you want to do in there.
You say a word on why Python?
Yes. The reason is over here in machine learning, mostly everyone uses Python. So all the libraries that you use for deep learning, machine learning, they are mostly based off of Python. So it's very natural that everyone in machine learning uses Python. There are other languages as well that people use, but the most common language is Python for machine learning. Okay, so if you have a separate environment for your projects, what you will mainly benefit is there will be no conflicts between packages between multiple projects. And then you can have consistent environments across different machines. So a common use case over here, in our thing over here, is that in the lab machine, we have a computer, we develop everything over there, and then if we want to run our code in the supercomputer in LCC, there is a different environment, and you have to make sure that your code runs here in the lab machine and also in LCC as well. So you have to create an environment over there as well. So you want the environment in LCC and in your lab machine, or maybe even in your home computer, all of them to be the same. So you don't want package discrepancy between environments. So you want to have the same thing. So having a separate environment using Honda can really help. So to do the these separate environments. Python has a built-in Python environment. You can use that to do it, but I personally prefer using Conda. So Conda has two versions. It has Anaconda and it has Miniconda. Both are interchangeable. You can use whichever you want. I personally use Miniconda because it's a lot smaller than Anaconda. Another good thing with Anaconda is that you can install it without sudo privileges. So you don't need to run to Tom and Kevin and say, please install this. So anywhere you go, any machine, you can just install it yourself. And you have a folder where Miniconda is installed and things are loaded from there. So it's easy to set up. You just download a SH file from the Miniconda website and run that, and boom, Miniconda is installed.
So for different environments, you install Miniconda in many places, or one Miniconda provides multiple environments?
One Miniconda provides multiple environments in one machine. But let's say in the lab machine that I use, in the CS home directory, in my home directory, I have set up Miniconda. So any lab machine in the CS department I log into, I get that Miniconda. But when I log into the machines in LCC, that file system is different from the CS file system. So I need to install Miniconda in LCC as well. And then whichever node I request, all of them are from the same file system, so it's not a problem. But different file systems, whenever you go, you need to have a separate Miniconda installation with you. Okay? So you can easily set up in different machines, and then you can also share your environment with peers or even with yourself when you're working lab machine LCC. You need to share that environment, so you can do that really easily. And that will be the topic of the next slide, which is to export environments. So you've installed a lot of pip packages. Normally what happens is that if you don't have an environment file or something like that, basically what happens is that you download a code, you run it, it says, could not find this package. And then you do a pip install that package, run again, you get another error, you do pip install, and iteratively you solve it. That is a very inefficient way, and we want to move away from that. So for that reason, what you could do is you can export your environment using an environment.yaml file, where you'll say that, okay, for this environment, I have this package and this version. So in the picture that I have over here, I show an anti-pattern. This is how you should not export your environment.yaml files. So why is that? You see over here, let's say, so let's look at this, futures. So it has 3.3.0. So you'd want to have only till this much. You don't want this extra thing on the right. Then over here, you don't want this extra numbers over here. So what this does is that whenever you install a package, it adds some extra information that is local to this machine and this environment that you have. So basically, when you want to export your environment, you should have only the package name and the version number. So you want futures 3.3.0, that's it. You don't want anything on the right. So basically, if you have something like that, then when you want to install this environment in another machine, it will give you a lot of problems. So you say, did not find this, did not find that. So how do we do that? After searching in Google for a long time, I found out a way to get rid of those, and that is using this command over here, where you say the no builds. So these are actually build version numbers or build hash characters. So you don't want that to be part of your export, and then you do some grep to remove some other extra things as well. So this command I have in my GitHub gist as well. So if you go to my GitHub gist, you'll see I have a file called conda export, and you can use that is this command over there, and you can use it to export your conda environments.
What is gist?
Gist is just sharing code snippets.
Okay.
Have gist in GitHub, or let's say one file, one command. Okay. Next thing I want to talk about is some good practices that I follow when I'm writing Python. The first thing that I want is I want to have a good linter. So the good linter over here basically means that I want to be consistent with how my code is formatted. Because many places you'll be like I put a space, or let's say for tabs or other things, basically what happens is that you want your code to be formatted always at the same time. And the black formatter I found this to be really good, so I just use that. So that basically formats my code in a nice way that's really nice to look at. So let's say this bracket could be over here if I write it, but the linter moves this bracket down, so it's really easy to see. And I don't need to worry about all those formatting myself. The linter does that automatically. So I would suggest all of you to use a linter if you can. And also the linter helps with, let's say you work with one of your teammates and they don't have a linter. When you get their code, if you have a linter, you automatically lint everything and your Git commit will have lots of changes. And those are all formatting changes, those are not code changes. So that could be a small issue as well. Now,
It's called a linter, it's really a code format.
yes, code format.
Because a linter originally was something which checked for type consistency.
Yes, but over here it's like it does that as well. But since Python is dynamic typing, that's not a big focus. It gives you a red curly, but it's mainly used for code format.
Yeah, this is usually the kind of thing that's called beautifier.
Beautify, yes. So the next thing that I want to talk about is have method argument and return type typings for this. So you see over here, I have a slot name, I typed it as a string, and then return type is boolean. Yes, Python is dynamic. You don't want to do that, but we're doing that over here. The main reason for that is that later on, when you will write your own code, you want to make sure that, okay, what type of parameter is it over here? For basic literals like string, int, it's not a big deal, but if you have complex object types where you pass in your own object types, at that point it will be really handy if you have the tagging of that object over there. Then you know that, okay, if I need to call this, then I need to construct this object and pass it over there. And then in many cases, if you are returning complex object, then your editor will get to know that because you have linter over there, and then you can do dot and then get indexes as well. So that is advantage of using typing. Yes?
I've also found that adding type hits to your code helps if you're using your real IDE, it helps the autocomplete to figure out what you're trying to type.
Yes, that's basically what I'm saying. If you return a complex type, then the IDE will automatically know what this variable's type is, and then when you write the variable name and then press dot, it will say, okay, these are the features that are there in this variable. So that's really handy, and you can really quickly write your code. And you won't say that, okay, this variable's name is, let's say, typos in your code will reduce because your IntelliSense is suggesting the actual correct variable names. So there have been cases where if you use dynamic languages like JavaScript and Python, you make some small errors to your variable names, and it takes you hours to just figure out where that small typo was. So that's some good things you can figure out. The next thing that I want to talk about is to use the string join function instead of manually concatenating it with plus and all those things. So this is something like, let's say when we have some path that we want to construct, or let's say we have a string. Over here, basically, let's say I have a string representation of this class where I have name, description. So I have some special tokens I want to wrap them around. And you can see I use the join method. This thing, what you have over here, will be the string character that will be used to join multiple variables. So it's always a good practice to use the string join rather than using the class and then this string. That way it will reduce the typo errors that you could have. Yes?
Along with string join, there's also things called f strings.
Yes,
where
yes.
F in front of the string literal. So you
Yes.
can put
So
variables in
we can
there.
use f strings as well, but it's interchangeable, whichever one. So if you have, let's say, 6 or 7 things you want to join, then I feel this is much better than using an f string. But if you have, let's say, 1 or 2 things you want to join, then maybe f string is much better than using
F strings are also useful if you want to have a lot of string literal.
Yes.
stuff.
I do use f-string a lot as well. But this is something that people normally don't use, so that's why I'm bringing it up. People use f-strings, so I didn't want to repeat it again.
Let me point out that in Java, it's much faster to use join.
Yes.
In JavaScript, it's much faster to do concatenation. So it depends on the language and its implementation if you're worried about speed.
Yes.
Here you're worried, I think, about clarity.
Clarity, yes. Here I don't really worry about the code speed because there are other places where it's so slow, these optimizations don't really matter. And then also another thing that I want to talk about is you should use constants or enums instead of magic strings. So you see over here, I use special tokens of possible values, then special token, the n possible values. I could have written this special tokens as a string over here, but I chose not to. I chose to use an enum or a constant. That way, later on, if I need to make some small changes to this constant, I just need to make that change in one place, and it will be reflected in all places. But if I didn't do that, which I personally, when I started off writing a few projects, I would just write the string over here. And then when I had to make changes, I would have to go over 10, 20 files and figure out, edit all those things. And then when I run the code, I would see I missed out in a few places. So it's always a good practice to use constants and enums instead of like magic strings. That's the term we use. And also another thing that I would really encourage everyone to do is when you're debugging your code, or when something is not working in your code, try to use a debugger to find where it went wrong rather than using print statements, because print statements will just give you some value over there, and you need to do it multiple times. But if you use a debugger, you can see all the variables, and there might be some dependencies between variables, and you can figure all those things out. And many times it has happened where I started debugging in hopes of finding one bug, but I found 3 or 4 other bugs along the way because I saw that, okay, those variables had something different that I didn't want them to have, and that would give me more bugs. So these things you can easily figure out if you use a debugger rather than just printing statements. Another problem with printing is after you're done solving, you need to delete all those print things, and normally what happens is that stays. We are lazy to get rid of those, so that is also a problem of using printing to debug. Okay, so we went through some of the basics of Python environments. Now I'll talk about some third-party Python libraries that I frequently use, and I encourage you people to use as well. So the first thing that I use is a library called pathlib. So whenever you're dealing with file system and loading resources from the file, normally you have a string of a path. People concatenate that path and do everything in string. But I suggest to use something called a pathlib. So whatever path you have, pass it through the path object, and then you create a really nice formatted object from which you can get the name. Let's say you want the end part, you just want the name without the file extension, you can do that. You just want the file extension, you can get the file extension. Even if you want to navigate to the parent and all those things, you can do that really nicely. So normally, let's say you have a path, and if you want to know the parent, if you have that as a string, you have to pass a really complicated, or like you pass in a regular expression and then do some array slicing to do that, which is not the best way. If you just use the pathlib library, you can do all these really in a nice way. And then also, the good thing with this is that if you have multiple environments, like let's say Linux and Windows, the file system starts differently in both places. So you don't need to worry about those platform differences as well if you use pathlib. Okay? So yeah, and another good thing with the pathlib over here is that when you append to a path, let's say you have the root directory and then you want to add a base folder and then another file name, you can just use / and then it will append the paths for you automatically. You don't need to do anything super complicated. It's really easy. In the future, in some slides, you will see some examples of me using the / of pathlib. And yeah, it's pretty organized. Moving on. Another package that I frequently use is called TQGM. It comes built in a lot of libraries where it shows that if you're running a loop, it will show you what the progress of that loop is. Basically what happens is that, let's say I try some code, I run it, and I see just an empty black screen waiting for it to finish, and I don't know when it will finish. So sometimes maybe my program is very close to finish, I get like, I don't have patience and I just stop. But like if you have TQGM, you can see the progress bar, and then you can see, okay, how long it's going to take. And it also has some really nice features that comes in handy, is that it shows how long your each iteration takes. So that way you can optimize for like per iteration based thing as well, to see that, okay, are you doing something super complex in a loop which you could maybe not do or otherwise. Okay? So you can get progress bar and then get details about each iteration. And it's pretty simple to use. You just import the TQDM and then wrap it around an array, and then you look over it and you get automatic progress bars. Okay, next thing that I want to talk about that's really handy is called Python data classes. So Python data classes are, if you used other languages like Java, it's called POCO classes, plain old class objects. Pretty bare minimum class objects. So the good thing with using data classes is that you can initialize objects pretty easily. So you just, let's say this user, so you call the user, pass in 2 parameters, and then they will assign to whatever things you have over here. You don't need to explicitly name them, you can if you want. Then you can do comparison, sorting, all those things. The data class by default provides you a lot of helper methods like less than, greater than, equals, string, and all those things that you can quickly out of the box get. Let's say if you have an object, if you print it, it will give you just a memory location, which is useless. But data class will give you a formatted way of all the parameters that you have. So out of the box, you get a lot of really nice stuff. Then it has, as I said, a lot of useful representations in there, and you can add properties to add custom logic. So you can see over here in this example, they're adding a property is adder, and they check, okay, if the age is greater than 18, then this person is an adder. And so you don't want this logic to be somewhere else. This logic is related to this data class, so you want your logic to be over here. So this data class also allows you to put code where it should be. And you don't need to put another additional field over here, which is maybe not required for this. So you can have properties. And then it gives you really nice type hints and intelligence. As you can see over here, you're doing a for loop over all the users, and then you can see over here, it gives you all the method that is over here, and properties and things you can see over here, and the intelligence as well. So that is a big advantage of that. Then also you can use the object. Normally when we use dictionaries, we use strings, integers, and those things as keys. But with data classes, we can use data classes as dictionary keys because you can convert this data class into a dictionary. And another good thing is you can easily refactor it, make changes to these things, which is very similar to if you use classes as well. No big difference here. Another very big advantage is using inheritance. So normally if you use Python, when you have inheritance, basically in your child class, you need to yourself construct the parent class and then call superrun. But data class makes it really easy. You don't need to do any of it. They implement all of it behind the scenes for you. So you just do inheritance, and in your init function, you think that, okay, the parent class has been constructed, so you just move along with what you want to do. So the inheritance really helps over here. Okay. Another thing that I want to talk about is multiprocessing in Python. This is something that I struggled with for a long time. Like Python, with how it's structured, multiprocessing with Python is pretty difficult. I tried many times, and every time I would like fall into this error, that error, and it wouldn't really work. But then finally I figured something out with this pathos package, and they really helped make the whole multiprocessing in Python really easy. So the first thing about multiprocessing that I would suggest is you should use the multiple cores in your machine. So multiprocessing mainly enables you to use all the cores. Normally, most of these machines right now are up to core or 16 cores. Normally, when we run our code, we only use one core. All the other cores are not used. So in some resource-intensive situations, you would want to use that. So the way to do that is to create processes instead of threads. If you create threads, they will run on a single core. But if you create processes, each process will be executed in a separate core. And that way you can utilize, let's say, all 16 cores in your machine. So the way to do it is you import the pool from the pathos multi-processing, and you can just, let's say you have an array that you want to call multiple times, you can just pass that using that pool, and then you can get it. So if you have additional arguments that you want to pass to your method, you can do that using repeater tools repeat. And then if you want to get a progress bar, you can get the progress bar which you need to get. So I have an example over here. Basically, what I want to do is I have, let's say, 150 dialog files that I want to process. And normally, if I didn't do multiprocessing, it would take me around 8 minutes to do it. So I would have to wait 8 minutes for it to finish. But if once I was able to add multiprocessing, it got done within 1 minute or less. So basically, what I did over here is that, I want to call this file prepare dialog file over all the dialog file paths that I have. So you can just call pool.imap, and then over there you say the function that you want to call, and then you pass in the additional parameters that you have. So over here I have a list of dialog paths that I pass, and then let's say I have some additional parameters I want to pass. I pass that over here as well. And then inside this function, you just write your code the way you want to do, as if you don't need to care about multiprocessing over here. You just write regular code over here, all the multiprocessing is done over here, and then finally you get the results in this variable over here. So it's really plain and simple. You just need to just add this one thing, and then maybe add iterative repeat for the additional parameters for the function. It's not super complicated, and it really will help you when you're processing multiple files, or let's say requesting things over the network, or doing CPU intensive things. You can do that using this multiprocessing and use all the codes. Okay, moving on. So we went through some of the stuff. Now, another important stuff is command line arguments. So let's go over here. So let's see some examples of command line arguments. So let's see over here, we have the popular ls command, and then you can pass in extra arguments as such over here, which directly you want to see the ls from. Now, why do we need command line arguments in our code? The reason for that is we don't want to have hard-coded variables in our code. There are many cases where, let's say, you're loading data from a certain directory. Let's say in those lab machines, you have a lab file system, you load from a certain location. You go to LCC, you should load from a different location. It might not be the same over here. So if you have that hard-coded, then when you go to LCC to load it, then you need to change it. So these type of things that are dynamic, you can make them program arguments. That way, when you run your program, these variables will be set. And you can run multiple different experiments if you use command line arguments as well. So you can run things with different configurations, and you don't need to edit your source code. That's the main thing. We don't want to edit our source code all the time. We want to do as much customization from the outside so that we don't need to touch the insides of our code. Command line arguments really provide that. Then also, if you have command line arguments, you don't need to add a lot of conditionals in your code to check, okay, whether was this set, was that set, what is where are we right now? You don't need to do a lot of conditionals. You can reduce a lot of conditionals in your code if you have this. It adds a lot of flexibility. You can do lots of different things with just changing a few things, see a few variables in your code. And then it also enables you to design your code in a much better way. So how do we implement command line arguments? So the most basic way to implement command line arguments in Python is to use the argparse library. In many cases, just using argparse is fine. So I have an example over here. So if you use argparse, you're already in the right track. It's a good starting point. So you can, whatever arguments you pass from the command line, you just say that over here, and then you see, okay, the name I'm passing, age, and all those things, and then you can get that all in this args variable, okay? But there are some problems over here, if you can see already. It has a lot of boilerplate code. So see over here, we only have 2 arguments, and we're writing so much code, okay? So as your project becomes larger and you have lots of parameters, normally I've seen people just having one separate file just for this argument parsing. Okay, and it's a lot of overhead. And when you have to make small changes, you have to make changes over here as well. And it is a kind of challenge to maintain over time. And also, over here, what happens is that when we run our code or run different experiments, we want to have certain templates. Let's say an experiment A depends on these set of parameters. Experiment B depends on those sets of parameters. The way to solve this could be, okay, you write separate SH files, and in those SH files you provide the values for those parameters, and that way you can run. But still, it's a little cumbersome to do all those. So the way to do it, the way how I do it is using a package called Hydra. So the Hydra package basically, you provide your configuration in the form of YAML files. Okay? So this is a configuration file for, let's say, this program that you see over here. So as program arguments, I want to pass a trainer object that will have an optimizer. That optimizer will have some information related to that trainer, and then some information about the data set and all those things. And in your code, basically, you will get a dictionary, and then that dictionary will have all the properties that you have. So you don't have to write any extra code to parse those arguments. You just import the library, and you define a main function using Hydra, and all the arguments that you pass, you will get it as a dictionary, as a parameter in the main function. So it's as simple as that. Any changes you make it over here, and that will reflect in your config object you have out there. So it makes things a lot easier. And the main advantage of this is that, as I said before, for experiment A, you can create a YAML file with, let's say, these parameters. And for experiment B, you create a separate YAML file that will, let's say, change the learning rate. And other cases, let's say you're working on the lab machine, the path to the data set is over here. But let's say when you're working in LCC, path to the data set will be different. So you just override that over here. So that way you can easily manage multiple experiments, multiple environments, without making much changes to your source code. Yes? How much time do I have? Okay. Okay, so I guess I'm a little bit slow. Anyway, so that another advantage of Hydra is that it can create folders for your outputs. So you can see over here, all the outputs have a folder of the date and then a folder of when it ran. So all your outputs are sorted in separate runs. So you don't need to normally create the output directory yourself. It does that out of the box. And then also, when you run that experiment, it will show you which configuration you use to run that experiment. So that way you can look back and see. Normally what happens is that I run 5 experiments, I forgot what I did over there, which folders have which parameters. But you can exactly go in there and take a look at those parameters explicitly, and then you can see what you did. Okay. How I integrate Hydra, I don't want to go into this right right now because it will take a lot of time. Let's go into structuring the code base a little bit. So basically, it's a very bad picture, I know. When I did it, it came up like this, but I couldn't help it. So basically, when you structure your code directory, I would say have a folder for config, have a folder for data, then have a folder for your process data that you have, and then have a separate folder for your source, so that your source code is separate from all the other places, and then let's say other SH files that you have over here. So if you organize your code and different files in this way, that way it will really be easy for you to know, okay, where things are, and then you can use git ignore to ignore your data files and all those things so that it's not tried. Next, when you write your code, you should try to make sure that your code is like individual components. So basically, let's say I have a training script or training part. I want to make it an individual component. I have an inference part where I do testing. I want that to be an independent component. And then I have a data module and data prep. Since these are all individual components, the advantage of this is that you can make them so that they can run by themselves, or you can make sure that they can be consumed by other modules as well. Like let's say my trainer module consumes the data module, which calls the data prep, and then it trains, and then it can call the inference module and then do inference on it. So the inference module, on the other hand, can run on its own as well. So if you design your code in such a way that this is a component, it can run independently, or it can be consumed by someone else, then your code will be reusable. And so when you're modeling the data, the thing that I suggest the most is that do not work on the raw data itself. Create an intermediate data model at the middle and work on that model. So let's say you have a raw data that is in JSON format. So convert that raw data into a raw data model, make some changes to that, convert that to an intermediate process data model, and then that process data, you can save it as a CSV. If you do it this way, then you're not directly working with strings and directly working with JSON objects. You will work with class objects, and it will make your logic processing a lot more easy. Okay? So I have a simple example of how I process my raw data. So you can see over here at the top, I have JSON. So I convert that into a Python data class over here. So see the service name, description, all that. And then when I read it, I have, say over here, I'm reading this JSON file from here, and I loop through this, and I just can call the data class dot from it, and then I just get it in the class over here. So I don't have to write tons of code. This way, this data, instead of working with this, I will work with this class. So writing code is much easier if you work with classes rather than dictionaries of JSON objects. Okay? And you can add special methods in here related to this class, which you wouldn't be able to do if you had to do it like that. Okay? So I'm quickly finishing it up. So when you are training your machine learning models, you want to make sure you use a framework. Let's say Hugging Face for NLP. If you're doing computer vision work, use PyTorch or PyTorch Lightning. And one thing that I want to say over here is that make sure you're using the GPU versions and optimize your GPU. So the two things that I want to say over here is that you see this graph is the process GPU memory allocated. You have to try to ensure that you're using 100% of your GPU memory. That way your training will run faster. Another thing you want to make sure is that you utilize your GPU. So it's like GPU is being utilized 100%. If you do a lot of stuff in your training, the GPU utilization will be low, so your training will be slow. So it's good if you can monitor these two things when you are training your machine learning models. That your GPU utilization is high and GPU memory allocation, you're using all the memory that is over there. And there are cases where you cannot load a lot of data, there is a concept called gradient accumulation where multiple steps are accumulated together to get the grade. Okay. Another thing that I want to talk about is when you're running an experiment, you should use an experiment tracker tool. The one that I suggest is using weights and biases. So I have two examples over here that you can see here, which lists all the runs that I did, and I can see the state of it, and I can add some tags, I can add some groups, and I can see when it ended, and I added some notes as well, so that I can figure out, okay, what I did with that experiment. So I can quickly go in there, I can see the run times, and I can also see Java items. You can do that, and for each particular experiment, you can also log your own data. So over here, I log the table where I have different metrics that I will calculate. I just log that as a data frame, and then you can also see some graphs of how your training is going. So this provides a really nice. There are some alternates, but we can discuss about that later. And then I suggest you have a research journal when you're doing your projects. In that research journal, I do that using a tool called Obsidian. That's a separate topic of discussion. And then over there, basically, I try to do weekly progress updates where I say, okay, this is what I did here, this is what I did. And then when I have experiments, I log the experiments and results. So I say, why did I do this experiment? What I achieved from here, and then the result that I got from there, so that I can quickly view and compare future experiments with. And also in your research journal, I do concepts that I have, ideas that come up, I log those over there. And let's say when I'm reading some papers that I feel would be useful, I just add that paper summary over there. So later on when I'm writing a paper in the related works, I can go through, let's say, this summary that I had over here and quickly get an idea of what this paper was about. So to summarize, in this presentation, I basically talked about an IDE, Python environments, command line arguments, and how convert raw data to intermediate steps, how you should structure your code, make it certain directly, make it modular, utilize the GPU, and then use an experiment tracking tool to track your experiments, and then keep a research journal so that you know what you're doing when you are in your research. Okay, so that is all that I want to talk about in this seminar. Any questions? Welcome.
I don't know if we have time for questions. I have a question myself, but thank you very much. It's already 12.
Yeah, sorry.
Fine. If you have questions, please ask them after the talk or when you have pizza. Thank you very, very much.
No.